So a couple of different ways to do that. One way would be moving the x squared. And that's perfectly legal to do. But what does that put in front of the x squared if you move it? A negative. If we were factoring, that makes it harder to do. But since we're doing quadratic formula, it really doesn't make it that much more difficult. So I think that's the quickest, most direct way to get a result. Okay? So I'm going to list A, B, and C. Since we moved that over, A is now -1, B is, and C, okay. If you didn't want the x squared to be negative and you decided to move the 6x and the 4, that's absolutely fine. It's going to give you the exact same answer. Okay, it just takes a little bit of work. Same amount of work to do it either way there. Okay. Now, let's do to the discriminant. Always going to do that. If we're solving by quadratic formula, I want you to do that discriminant first every time because it makes it easier than trying to just put it all in that quadratic formula all at one time. It also gives you a clue as to what you're supposed to be finding. Okay, so b squared minus 4ac, 6 squared minus 4 times -1 times -4. Got a lot of negatives in there. You got to be careful. 36 minus 16. -4 times -1 is +4 times -4 comes back to -16. So the discriminant is 20. What does that tell us about our problem? 2 real solutions. Okay, 2 reals. Okay. All right. Let's work it out. -b, -6 plus or minus the square root of 20 divided by 2 times a. And we try to simplify. What do we know about the square root of 20? It breaks down, doesn't it? There's a pair of 2's. So that's going to be -6 plus or minus 2 radical 5 all divided by -2. And we're going to simplify a little bit further. We're going to split it apart. Remember, that's what we're going to do every time. So when I split that apart, it'd be -6 divided by -2 plus or minus 2 radical 5 divided by -2. Well, what's -6 divided by -2? 3. +3. Be careful of that. What happens here with this 2 on the outside and this 2 down here? They're going to cancel each other out. Here's the thing that can never happen. This number in the bottom can never cancel out what's inside of the radical. Okay? Never, ever. Never, ever. Okay? A integer in the bottom can never cancel a number that's underneath the radical. Can only cancel numbers that came out of the radical. Okay? So technically what happens here is when you divide by -2, it would flip this symbol to be minus plus, but I never write it that way. You may encounter a book or maybe Khan Academy may flip that over, but it doesn't really matter. Plus minus is the same thing as minus plus. Okay? Because they're dividing by a negative, negative changes the sign of everything. So I always just write it this way, plus or minus. That's just how I always write it when I'm doing it by hand for sure. 3 plus or minus the square root of 5. Again, we're going to leave that exact solution. If we wanted to get a decimal approximation, we do 3 plus whatever the decimal for square root of 5 is. And then we do 3 minus whatever the decimal for square root of 5 is to get that. Okay. All right, let's look at C. -x squared plus 4x equals 5. What do we got to do first? Get it equal to 0. So we're either going to move x squared and 4x or the 5. I'm going to take the quick way and move the 5. And then either write it down or have it in your brain what A, B, and C are. A is -1, B is 4, C is -5. Get the discriminant. Four squared minus 4, bless you, multiple seizures. I always put those in parentheses. That way, if I go to put them in the calculator, I make sure that I put them in parentheses when I type them in there as well. Okay, that's just a good habit to get into with these numbers, because the sign, if you happen to have B as being a negative number, which none of these have yet, when you put that in the calculator, you definitely want it in parentheses, because it won't do it right if you don't. Okay, so that'd be 16 minus 20, which is -4, which tells us what about our solutions? Two complex solutions. All right, fun. Got a complex thing. Okay. X equals -b plus or minus circle. B squared minus 4ac divided by 2a. Makes it fun. All right. So plugging that stuff in. Simplify what can be simplified. Okay. So I know the 2 times -1 at the bottom. That's the easy one. I'll do that one. Y'all do the other one. What's the other place it can simplify? That square root of -4. What does that become? 2i. Square root of 4 is 2, because it's negative under there, an I comes out as well, so it's plus or minus 2i. Then we're going to split it apart and write it as a standard form of a complex number. Remember, complex numbers had that form A plus BI. That's the way we wrote them. Okay, ours is just going to have a plus or minus in the middle of it. Okay, so we split that apart: -4 over -2 plus or minus 2i over -2. What's -4 divided by -2? +2. -2 goes into 2, -1 times with the I. Technically, that would flip that plus or minus into minus plus, but I always just write it plus or minus because it's the same. I. 2 complex solutions. One is 2 plus I. The other one is 2 minus I. Easy stuff. I don't think in Algebra 1, you didn't have complex solutions when you did quadratic formula. We had all of them that had either real, 2 real solutions or 1 real solution. So complex numbers mixed in here is a new thing for this. Let's do this one. This one's a little tougher. 7x minus 5x squared minus 4 equals 2x plus 3. Now that's a little bit more Algebra 2 like. 7x minus 5x squared minus 4 equals 2x plus 3. Was there anybody that wanted second chance this morning? I can put this out there. Let's see. It's okay if you do. I tell you, they tell us they're going to do that this morning. So tomorrow we'll start on the Tuesday column and get that. When you come in, just go ahead and sign up for it. All right, what do we do first? Get it equal to 0 and get it in the right form. Okay, so what can we do to do that? Okay, if we subtract 2x, we're going to subtract it from the 7x. What else would we do? Yeah, we subtract 3. And I'm absolutely fine with you doing those 2 steps at once. I expect you to, actually. So these cancel. There's our 0 that we want. And now, when I do this work, I'm going to go ahead and rewrite it in the right form. What should come first? Negative 5x squared. And then what's 7x minus 2x? 5x, right? So plus 5x. And then minus 7. Okay. So that puts us in standard form for a quadratic. And we're ready to do quadratic formula. If I were going to try factoring here, I would probably divide everything by -1 just to change the sign. But since we're kind of focused on quadratic formula today, I'm just going to leave it like it is. So -5, +5, -7. Let's get that discriminant. 5 squared minus 4 times -5, -7. 25. 5 times 4 is 20, times 7 is 140. It's 3 negative, so it'd be a minus 140. -115. Does that tell us about our problem? Two complex solutions. Okay. Jump to your quadratic formula. X equals -b plus or minus radical b squared minus 4ac divided by 2a. Right. What can be simplified? Yeah, that'd be -10 on the bottom. What about the square root of 115? 115 is kind of a weird number. We don't know much about it, other than it's divisible by what? 5. And it goes 23 times. 23, though, is prime. So does that have a square root that comes out? No. Okay, so what is the only thing that can come out of that radical? An I. Because it's a -115, we pull that I out, and 115 stays on the inside. Okay. Next thing to do is what? Split them apart. We got -5 divided by -10 plus or minus I radical 115 divided by -10. And then simplify those. 2 plus or minus, or not 2, 1/2 plus or minus. Now, can I simplify the 10 and the 115? Why not? 5 goes into both of them, though. But one of them is where? Under a radical, so it's locked up. You can't do that. If it's under the radical, you cannot simplify like a normal fraction. You only can do that if it's a number outside of the radical. So this one, we're going to leave it. I'm going to write it like this. Radical 115 over 10, and then put the I after it. You might see it this way. I glanced at the Khan Academy this morning. I'm not sure how I think this is the way they write their answer. It may be this way, though. But we'll see as we get into it there. They'll have a little clue as to how they do that. Okay. So we've done a couple of them that have complex solutions. We've done a couple that had real solutions. 2 real solutions. Let's look at another one here. 4x squared minus 10x equals 2x minus 9. What do we do first for this one? Okay, subtracting 2x and adding 9 would get it equal to 0. That's a good idea. And that cancels out everything on that side. So 4x squared minus 12x plus 9. Again, I'm going to list A, B, and C. 4, negative 12, 9. And then we're going to go find that discriminant. All right, negative 12 squared is how much? 144. Positive or negative 144? Positive. Anytime you square something, that should turn positive. And then we have negative 4 times 4 is negative 16. Negative 16 times 9 be 90 plus 54, which is 144, and it's negative. Oh, wow. Our discriminant is? Okay. That means this is an easy one when that happens, okay? So, if the discriminant is 0, then that makes the quadratic formula super easy. So negative b would be 12 plus or minus the square root of 0 over 2 times a, which is 2 times 4. What's the square root of 0? 0. So if I add 0 to 12, what do I get? 12. And if I subtract 0 from 12, what do I get? 12. All right, so I'm just going to get 12 over 8, no matter what there, because I got a 0 there. Okay, and can we reduce that fraction? Yeah, 4 goes into both of them, right? 3 over 2. That's our only solution here, is 3 over 2. That's nice when the discriminant is 0, because it makes that super short and easy. But it's the same process, though, as we did before, because instead of having to break down a number here, we got 0. The square root of 0, when we simplify that, is 0. And we just went ahead and did that math. We know if we add or subtract 0, nothing's going to happen. Let's do one more. I'll take it easy on you and give you one that's already in the right form. And make the numbers fairly small. All right. It's already in the right form. It's equal to 0. We're ready to go to work on this one. What's A, B, and C? 1, negative 7, 12. And then we go just find that discriminant. Negative 7 squared minus 4 times A times C. So it'd be 49 minus 48, which is 1. What kind of number is 1? It's perfect square. It's the perfect square we usually forget about. We look for 4 or 16 or 25, stuff like that. But 1's a perfect square as well. So that means when we take our square root, we're going to get a nice easy number. Okay? So we go to do our quadratic formula, negative b plus or minus the square root of b squared minus 4ac. We know that's 1 over 2 times a. Simplify what can be simplified. So that's 7 plus or minus square root of 1 is 1. So we end up with a pretty easy problem. It's got easy numbers in it. We got 7 plus or minus 1, and then all that divided by 2. Anytime that happens, you get a perfect square for your discriminant. Then go ahead and work that out. Do 7 plus 1 over 2, and do 7 minus 1 over 2, and work those out. So 7 plus 1 would be 8 divided by 2, which is 4. 7 minus 1 would be 6 divided by 2 is 3. Because that was a perfect square there, we know that this would have factored. It would have actually factored as x minus 4 and x minus 3, which would give you the same answer as positive 4 and positive 3. Okay. There are times when factoring is quicker. Factoring would have been quicker than this if we recognize the numbers. If you don't recognize the numbers, then factoring probably isn't quicker because you're having to guess and check and all that stuff. So quadratic formula is always nice when you recognize the numbers. All right. Solving by quadratic formula, that's our goal today. On Khan Academy, you've got a few lessons there available to you to practice that. And so you'll have the rest of today, which is about 40 minutes of class left today. And then tomorrow we'll work on that some more. Quiz Wednesday over quadratic formula. Okay, Quiz Wednesday over quadratic formula. I haven't got them all graded yet. I'm working on that. That's part of my plan today. Okay. Yes, Quiz Wednesday, test Friday. All right.